Welcome to The Explainer, where we break down big ideas. Today we are tackling a question that could seriously change how we look at everything. What if all the weirdness, all the unpredictability of the quantum world is just a shadow of a much simpler, bigger reality that's hidden from us?
Okay, let's just dive right in. At the heart of modern physics, there is this massive mystery. We're always told the quantum world is chaotic, it's random, it's unpredictable. But every now and then, physicists find these quantum systems that are perfectly orderly, like clockwork predictable. So the big question, the one that's been bugging people for decades, is simply why? What gives? So, to really get a grip on this puzzle, we first have to talk about the fundamental rule of the quantum world. And this rule basically says that chaos isn't just common, it's the universe's default setting.
And that rule is the famous Heisenberg's uncertainty principle. Now, this isn't about us having shaky hands or bad equipment. No, this is a fundamental fuzziness that is literally woven into the fabric of reality. It means the more precisely you know where a particle is, the less you can possibly know about where it's going. The universe, at its very core, is fundamentally unpredictable. And that fuzziness leads to something really critical. The order you do things in completely changes the result. Measuring a particle's position and then its momentum gives you a totally different answer than if you measure its momentum and then its position. In physics, this is called non-commutative, and it's basically the ultimate recipe for chaos.
And right here, this is our central mystery in a nutshell. If the whole universe is supposed to be chaotic and non-commutative, why in the world do these perfectly predictable, orderly systems exist at all? It's a huge contradiction. It's like you're hacking your way through a wild, untamed jungle, and you suddenly stumble upon a perfectly paved, straight-as-an-arrow highway. It just shouldn't be there.
So how do we possibly solve this? Well, there's a new theory that has a truly mind-bending explanation. And the first clue? It comes from the art world, of all places.
This is the key idea from a physicist named Nikita Nekrasov. He basically says, hey, what if this weird orderliness isn't a glitch? What if it's a clue, a sign that we're only looking at a piece of the puzzle and not the whole thing?
And here's the analogy he uses. It's brilliant. So there was this artist, Kazimir Malevich, and he's famous for his painting Black Square. To most people, it's just what it sounds like, a flat 2D shape. But his followers understood something deeper. When he died, they didn't put a square on his tomb. They put a cube.
And that one simple act completely reframes the whole problem, doesn't it? The square was never the whole story. It was just a shadow, a projection of a much more complex, three-dimensional reality. The simplicity of that flat square only makes sense once you realize it's just one side of a cube.
And this is where we take the big leap. What if those weirdly orderly quantum systems seem so simple and predictable for the exact same reason? What if our view of quantum events, happening one after another in a line, is just a flat, limited perspective on a much richer, higher-dimensional universe that we can't see?
I know, it's a wild idea. It sounds like something out of science fiction. But to even begin to test it, physicists need a way to translate between the world we see and this hidden higher dimensional one. They need like a Rosetta Stone for reality itself.
And believe it or not, they have one. That Rosetta Stone is an incredibly powerful framework called quantum field theory, or QFT. It's basically the mathematical language that describes how all the forces and particles in the universe work. And crucially, it lets physicists translate the rules between different numbers of dimensions.
You can really think of it as a dictionary. Imagine finding two ancient books in different languages that seem to be telling the same story. QFT is the tool that lets you go line by line and see if they really match up. It lets physicists check if a simple 1D quantum system is actually just a different language for talking about a complex reality in more dimensions.
Okay, so theory time is over. Let's put this so-called dictionary to the test. Let's take one of those surprisingly orderly quantum systems and see if we can crack the code.
Our test case is a classic called the Heisenberg spin chain. It's basically a line of little quantum magnets, or spins. And here's the key. It is one of those perfectly orderly, commutative systems that by all rights shouldn't exist. For almost 100 years, it was just this beautiful but kind of isolated mathematical curiosity.
And that's all it was for a long, long time. Then, 60 years after it was first described, physicists who were working on something totally different, these higher dimensional theories, they stumbled on something incredible. They found that the complex, hairy equations they were using to describe particles and forces in a two-dimensional universe were identical to the simple equations that Hans Bethe had written down for that one-dimensional spin chain 60 years earlier. It was a perfect match. The dictionary worked. Two completely different worlds were actually describing the exact same thing.
And when you look at the translations, it's just astonishing. Everything in the simple 1D spin chain has a direct twin in the 2D theory. The strength of the interaction between the little spins, that just corresponds to the mass of a particle in the other world. But that last line, wow, that is the one that changes everything. The very number that makes our world quantum, a thing called Planck's constant, it corresponds to the speed of a rotation in that hidden, higher space.
Okay, this is where it gets really, really profound. If the very thing that defines quantumness is actually just a feature of a hidden geometry, what in the world does that mean for our reality?
So, Planck's constant, this little symbol h, you can think of it as the volume knob for quantum weirdness. It's what separates our everyday world from the bizarre world of probabilities and uncertainty. And for a century, everybody in physics has considered it one of the absolute, fundamental, unchangeable constants of nature.
But this research just completely flips the table over. It suggests that Planck's constant might not be fundamental at all. It might just be a property of geometry, like the speed of a rotation in a space we can't even see. The quantumness of our world might not be a basic rule. It might just be a consequence of the shape of this hidden reality.
So, let's bring this all home. What this all suggests is that the weird, confusing, probabilistic rules of quantum mechanics, they might just be a grand misunderstanding. We might be like characters drawn on a piece of paper, thinking the whole world is flat and 2D, completely unaware of the third dimension all around us. The weird rules we see might just be the shadow of a much simpler, more elegant, geometric reality.
And that leaves us with a huge, and frankly, a pretty unsettling question. If something we thought was as fundamental as quantum uncertainty is just a trick of perspective, what other core features of our reality are just shadows? What else are we only seeing a tiny, tiny piece of? It's a question that really pushes the boundaries of what we think we know about our place in the cosmos.